Hi learners, welcome back to DHILK. In today's video, we are going to discuss about two important reduction reactions from carbonyl compounds, Clemmensen and Wolff-Kishner reduction reaction. So at the end of this video, you will be able to differentiate between Clemmensen and Wolff-Kishner reduction reactions. So watch the video till the end, don't skip any part. So let's get started. So firstly, we can look at the basic difference between these two reduction reactions. Both Clemmensen reduction reaction and Wolff-Kishner reduction reaction is a type of reduction reaction in which carbonyl compounds are converted into hydrocarbons. In both of this reaction, the reactant is a carbonyl compound and the product is an hydrocarbon. Okay, the difference is only in the reaction conditions. Okay, reaction conditions. So we can check this difference. In Clemmensen reduction reaction, we start from the carbonyl compounds aldehyde or ketones. We use zinc amalgam in concentrated HCl. So what are the reagents? Zinc amalgam and concentrated HCl. Then as a result of this reduction reaction, we will get hydrocarbon and water molecule. Okay. So what is Clemmensen reduction? Clemmensen reduction is a reduction reaction in which carbonyl compounds are converted into hydrocarbons in presence of zinc amalgam and concentrated HCl. And as a result, what is the side product formed? Water molecule is released. Okay. Now look at the Wolff-Kishner reduction. So what is the reactant? Reactant is carbonyl compounds and product is hydrocarbons. Now the reaction conditions. What are the reagents we are using for this reaction? We will use hydrazine. Hydrazine is NH2, 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 NH2. This is hydrazine. So carbonyl compounds in reaction with hydrazine, it will remove a water molecule and it will produce C double bond NH2. This is known as hydrazone. This is hydrazone. Hydrazone. And NH2, NH2, this is hydrazine. Hydrazine. So carbonyl compounds in reaction with hydrazine, it eliminates water molecules and form hydrazone. Hydrazones on reaction with potassium hydroxide in a high boiling solvent such as ethylene glycol and heating, it will produce the corresponding hydrocarbon. So what is Wolff-Kishner reduction? Wolff-Kishner reduction is aldehydes or ketones on reaction with hydrazine produce hydrazone by removal of a water molecule and followed by heating in presence of potassium hydroxide or sodium hydroxide. In a high boiling solvent such as ethylene glycol, it will produce hydrocarbons. This reduction reaction is known as Wolff-Kishner reduction. Wolff-Kishner reduction. So why this is a reduction reaction? So you can see what is happening here. Carbonyl compound on reagents are different in both of this reaction, but common we can say using the reagents it is converted into CH2. So there is addition of hydrogen, right? Here in carbonyl C double bond O is changed into CH2. So there is addition of hydrogen. So we know what is reduction reaction. Reduction reaction is either removal of oxygen or addition of hydrogen. So here is addition of hydrogen is there. So because of this is a reduction reaction. Now we can differentiate between Clemmensen and Wolff-Kishner reduction reaction. So basically we can say in Clemmensen reduction, what are the reagents? Zinc amalgam and concentrated HCl. So this reaction is happening in acidic medium. While in Wolff-Kishner reduction reaction, the reagents are hydrazine, potassium hydroxide in solvent like ethylene glycol, right? So potassium or sodium hydroxide. So this is in basic medium. So we can say the medium in Clemmensen reduction is acidic while in Wolff-Kishner reduction is basic. And reagents in Clemmensen reduction is zinc amalgam and HCl. In Wolff-Kishner it is hydrazine and potassium or sodium hydroxide. And what are the conditions in Clemmensen reaction? This is acidic environment. In Wolff-Kishner, the high temperature. This is the conditions. Okay. And what are the uses? And in Clemmensen reduction reaction, we can use for the compounds which are acid stable compounds. While in Wolff-Kishner reduction reaction, we can use the compound which are base stable compounds. Okay. Now we can say what is in both of this Clemmensen and Wolff-Kishner reduction reaction, what are the similarities? They convert in both of this reaction, carbonyl compounds are converted into hydrocarbons. This CO group is converted into CH2 and removes oxygen and add hydrogen molecule. So both of them are reduction reactions. Okay, that is the difference between Clemmensen and Wolff-Kishner reduction reactions. So finally, we can say both reactions are used to reduce aldehydes and ketones into alkanes, but the choice depends on whether the compound can tolerate acidic or basic conditions. Clear? So make sure rewatch this video if needed, practice the concepts, get fully comfortable before moving on. Then if you are a class 11 or 12 NCERT student and want complete materials, notes, tips, tricks or live classes, one-on-one sessions, visit our website or contact us through the number. Check the description box or comment section for more details. If you found this helpful, don't forget to like, share and subscribe and turn on the notification bell. Thank you for watching. See you in the next video.